Okay, let us go ahead and get ourselves started again. What we've been playing around with is just this whole notion of dividing up the surface and applying both sort of beam elements, any sort of adaptive point or element that could use a couple different points, like these beams, as well as dividing it up into these quads, which can then go through and place these surfaces. And a couple of questions that sort of come up out of that. One question is really just on my surface here, you'll notice that the beams, the cross elements, are actually hanging a little bit above the surface right now. And why is that versus the panels, which seem to be right on the surface? And it really just has to do with the granularity of how we've divided this up and how closely it can follow the true surface. What's happening is the panels are actually defined like on the surface, on a grid. It's reading those very, very accurately in terms of what's going on. So those, at all those different points, it's doing a very good job of approximating the surface. What's happening is for the beams, we really divided that up into a grid so that there's really only 3 control points. It's the ends down here, the middle, and the end on the other side. And what it's doing is it's approximating a curve between those 3 different things. So because that grid is, or the number of points being used to control that curve, is separate, or it's a little bit different from where the panels are being placed. The panels are actually doing a finer job because they have more control points to go ahead and lock to. So what we could do is if we wanted those beams to follow more closely, we could go through and just break the grid up into a finer number. So it's not just being divided by 3 for the beams, but then we'd have to go through and change our adaptive beam component so it also had kind of more points to work with. Okay. And in terms of doing that, that's not too awfully bad. Although now I won't demonstrate it. That'll get me down a rat hole. So, but we could go through and adapt that and kind of put more different points in there to go through and give that a little bit finer control. Okay, what we want to do though is start thinking about now, okay, great, we got all this geometry, it's looking pretty good in terms of what's going on. How can we kind of take it to sort of the next step in terms of being a little more useful? And the fact that we're actually able to generate like all this geometry actually is pretty useful in a number of standpoints. Let's just kind of pause and stop and look at that for just a second. For example, each of these different panels that is hanging around out here on the surface, we do know some stuff about it. We know what the area of the panel is. We can measure different things about that. We could ultimately use all these different panel definitions, send them out for some sort of fabrication instructions. Okay, so, no matter what the form is, we can go through, and each of these panels is understood individually, so we can figure out what the bar lengths are, what the size of the glass panel. We can do whatever it is that needs to happen to kind of really go through and make an entire facade out of this following whatever pattern, and have that all generated programmatically. So it's very, very useful. I think one of the most interesting uses of this kind of technology is people are doing it's just when you can use the model to actually start trying to dictate, fabrication or customization of pieces. And we now have the ability to, given almost any geometry that we're throwing at the system, the ability to go through and use, computation to figure out, what the specific points are, or, what the attributes of different panels are without having to do that manually. But where it starts to get really interesting is, we can now start really customizing all those panels so it's not just the same panel everywhere. We'd like to actually start thinking about customizing those in different ways, and there's different things we could think about. We could go through and if there were some sort of attribute to this panel, for example, we could go ahead and define a panel that has, some amount of closure, or some amount of opacity versus some amount of transparency, different amounts of area, kind of each of those different things. And what we can start thinking about doing is for each of those different panels, going through and adjusting that. We can think about really ways we could do that. We could also think about, putting some sort of shades or fins or something like that on the panels, and again, adjusting them kind of in some sort of smart programmatic way. So as you think about different things to have the panels respond to, okay, one of the strongest elements, one of the kind of really good ones to start thinking about is really what the relationship is to the sun. Okay, because as the sun goes through and moves through the sky, you'd start to see that, every different panel there in the surface, okay, it's facing a slightly different direction relative to what's going on in the sun. And we can start, really adjusting the properties of those panels so that, if ones that were sort of very closely oriented or facing directly in the sun, we want to put more shading on because we're worried about kind of a cooling, measure, we could go ahead and take a look at that. We could also think about really which of those different panels is the most ripe for collecting some sort of solar radiation. If we were going to go through and, either whether you want to look at it positively or negatively, it's helpful to start thinking about each of those different panels on this whole surface and really, which ones either have good sun or don't have good sun, and really how you want to go through and use that information. So to get going down that path and really start to understand, okay, of all these different panels, what can we do with them relative to the sun? What I actually want to do is back off a little bit and actually take a look at something a little bit simpler, which is just, if we just had a whole bunch of panels and sort of set them all in a row, can we get those things to follow the sun? Just how does the sun path sort of fit into this? And then we can then start using that information to go through and start adapting the panels. So here's what I have in mind. Let me kind of give you the general script of where we're going with this. So we divided a surface. We added some panels to the surface. What we're going to do now is basically head off a different way of really starting to think about responding to the environment. And for now, we'll look at the sun. We could also do this based upon wind forces. We can do it on all sorts of different forces we might want to go ahead and track. But here's the basic script of what we're going to be going after. If I want to create something that's going to follow the sun, the first thing I'm going to do is basically figure out, hey, where is the sun right now? Okay, and the good news is we can figure that out. There's actually a variable for telling us at any point where in the Revit model right now the sun is considered to be, and it'll actually just sort of return the point where that's located. Okay, what we want to do then is basically figure out if we, from any point in our geometry, really want to basically create a vector which is pointing from the face of whatever this is to the sun. Okay, just go through and compute really what that vector has to be. Okay, what they're going to call it is a transform, but we're going to figure out really how we have to point things to get them to face the sun. Okay, and if the sun were the projector, here I'd be facing it, whereas if I was over here on the left side of the room, now I'd be facing it. And the idea is to figure out really what is the vector that I have to apply in each different space so that no matter where I am, I'm always facing the sun. Okay? And then really how we can then, as the sun moves through the sky, go through and adjust those panels. So you can think of this almost like a whole array of solar panels. And if we were trying to put them out in the desert and just maximize the impact of how much radiation they were collecting, we could just have them all rotate through the day so that they're always following the sun. So we just get the maximum kind of normal, kind of surface area to collect as much solar radiation as possible. So we're going to go through, create some transforms, really figure out how they're going to do that. And there's a whole funny little thing about, figuring out basically the direction from the sun to each of the XYZ points, doing this little cross product thing, and I'm bad with some of the geometry here, but from this, kind of doing the cross product, which makes kind of the kind of perpendicular plane to the whole thing, and then using that to kind of figure out really what the transform is. So there's this whole thing of just really using the cross product function to go through and try and figure out if I need to point this way, what I need to kind of have the plane do relative to that. So it's always normal to it. Okay. And then finally, we're just going to go through and take these little rectangles and reorient them relative to that. So let us, with that as a starting point, starting with finding the sun path, then figuring out how to transform it, then creating some rectangles that do that. Let's see what that actually looks like. So come on back over to Revit, and if you can, please go ahead and open with me. Let's take a look at the following the sun example. Take a look at what's going here. Okay, so just in terms of sun path, so you know about sun path and how it all works relative to all this, is that there is always this notion of a sun path, and you can turn it on or off. I have it turned on right now. Let me turn it back on again. Then, based on really, the time of year and the date, okay, and a specific time, we can always figure out really where the sun is. So, for example, I go ahead and zoom on out. That's a very funny scale. Okay. As that sun moves around in the sky, you can sort of see what's happening with the shadow as the sun is moving around. And as we go through and adjust that sun path, there's a couple of different ways we can do that. You'll see I'm going through and messing around with it just by dragging the sun in the sky. It has a time as well as a date associated with that. There's a couple of sun paths that are easy to sort of work with if you want to too. You can just say, just take it to the summer solstice or take it to the winter solstice or the equinox, wherever it is. And if I go to the summer solstice, for example, you'll see the sun's pretty high up in the sky. If I instead change to the winter solstice, okay, the sun's very low in the sky. It's kind of amazing what a big difference there is, between those two different points in time. It makes a very big difference in terms of the shadows that we're casting. So you can sort of see the range between the summer to the winter and at different times of the day. Actually, this is also very sensitive to whatever the project location is. So right now, this is probably set for Boston, which I think is where most of the default stuff is set to. But if we need to go through and think about where the project location is, take a look. Looks like it's just the default location. If I instead want to change that to somewhere, let's think of a good place to put this thing. So Boston is where the default is. If I was going to change this to, give me a nice Quito, Ecuador. You'll see that there's not much variation when we're very close to the equator. Okay. Whereas if I instead switch to, let's go to another location. Give me a very far north or far south. What's very high? It could be in Asia, it could be in the US, it could be like Anchorage or Nome or something like that. See if I can figure that out. Okay. Very different range of values in terms of what's going on. So just so you're aware, go ahead and make sure that it's a reasonable kind of, the value of where you're evaluating the sun is kind of the appropriate environment for what you're going after. Okay, so that's just the notion of the sun. Let's just kind of stop there for a second. Does the sun path sort of make sense? How's that feeling? Pretty good? So change the location, and because I shaded it, what it's just showing me here, it's everywhere from the winter solstice, that's the summer solstice, and there's the equinox points in between. It's just kind of showing me the range of values. Okay, let's go ahead and we'll use that as our starting point for assumptions. And now we'll go through and start trying to basically think about some sort of grid of points that's going to be relative to this and use it. So how about this? Let's go out and go to Dynamo. And we're going to start by just creating a row of points. And if you can, please go ahead and open up under session 6. How about, let's say, follow the sun start. We'll go from there first. Let's take a look at what I've set up for you here. What I want to do is basically just start by just creating a series of X, Y, Z points. Okay, just a little series. I'm going to start at x value of 1. I'm going to go up to 20. I'm going to get 20 points, skipping 2 every time. So I should be getting a whole series of points, 1, 3, 5, whatever it is. So go ahead and say run that automatically. And let us see what this all looks like. That's interesting. Let me take out this other one over here because we'll use that later. Actually, it doesn't really matter. Yeah, I'll just take it out for now. I want to keep it simple for you guys, which is just to have a relatively simple array of them right here. Okay, and then let's take a look at how this all lays out. So I'm going to start with a number sequence, just 1, 3, 5, 7, whatever. I'm going to go through and make those a series of x, y, z points. And to make a nice just linear row, I'm just going to have that be the x values, y and z I'll leave set to 0. So come on over here. I should have a whole series of different points, just x, 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 moving along the way. Okay, from that, let's go ahead and think about what we're going to do. The key function to make this all work is this whole notion of the sun path. Okay, and what you want to do is basically use the sun path from the current view. So there's something called sun path direction. Okay, currently nothing's set right now. So if you want to go ahead and pick up where the sun's path is, okay, let's go ahead and say use sun path from the current view. Okay, what it's going to do is for the open document right now, it's going to grab where the sun is right now, just as a series of XYZ, its XYZ location. So let's kind of think about that. So it is right now considered to be at 34, 6, minus 93. So it's at a location right now relative to, the diagram. Okay. If I go through and move that, some other location, okay, it'll go through and change its coordinates in here. If I go through and move it to a different time of the year, okay, again, it's going to change its coordinates. So really, all that's really happening is the XYZ coordinates are just being changed, kind of based upon where the sun is in the sky right now. Right now, it's just saying in session still, because I've sort of manually put it at a location. But if you want to go through and be more precise, you can. Or actually not more precise, but sort of have it as a known value. I could say, let's take a look at the sun path. And let's go ahead and just make it like the winter solstice. Okay. Okay, and now it's going to go through and use the winter solstice location. It's just basically mapping that out. Okay, let's kind of think about what this is all about. Okay, there's really 3 functions that are going to work together. It's going to be called direction to XYZ, the XYZ cross product, and creating a transform. And let's think if we can kind of understand how they're all working. Direction to XYZ is really just saying, given the sun path and XYZ location and the XYZ locations on your grid, okay, that you set up, or this row that you set up, really, what are the, it's the points. Really, ultimately, what you're trying to do is figure out really what the vectors are. So what it's going through in there is basically indicating, from each of those different XYZ points, really, what is the direction you have to be heading out to? Okay, so you sort of see, the values vary as you go on down the list. Anywhere from -0.2 to -0.5. What we're basically trying to do is just sort of figure out, what is the scaling. Even in here, in terms of what's going on, you'll sort of see these are kind of going from the 0.8 to 0.97, minus 0.5 to minus 0.2. Yeah, this is really just setting a series of different directions. Okay, what we're going to do is take those same x, y, z points and the sun path and actually sort of figure out what they call the cross product. And I'm bad about the geometry here, but basically what we're going to do is, you know, for each of these different points, okay, and a sun location, okay, what we're going to figure out is, you know, what is the direction to each of those different points, okay, and then we're going to figure out is, okay, great, you know, what the cross product is doing is it's giving us that. Okay, so it's theoretically giving us all those little normals. Okay, finally what it's going to do is go through and say put a transform in there. Okay, that's basically using three different values. It's using sort of the origin, which is the origin being the actual x, y, z point itself. The up vector and what's considered the forward vector, where the forward vector is the cross product. So if the cross product is actually this, what we're basically now doing is on top of each of those different points, we're at an origin, so right at that point, we're putting a vector where the forward direction is the same as whatever the cross product was, okay? And up, that's just kind of coming out this way. It's just really indicating what the top of the transformation system is. So really what's happening is, if you come popping around back over here, let me see if I can pull those out of the way, and Control G my way in so you can see those a little bit better. Those are just a whole series of what they call transforms. Notice the green axis is always pointing up. The blue axis is the one that I believe is pointing towards where the sun is right now, and you can sort of see it rotates. Okay, as it goes through. So just depending upon how those points are moving, or where the sun is right now, those are going to rotate around so they're always pointing at the sun. So pardon that little bit of math. It's a little bit gross in terms of the cross product and doing this transform, but that's how we actually sort of make something which is a normal, which is perpendicular to the vector that points between where we are and the sun. Okay, that's a little bit mucky. We'll go back into the math of that a little bit later. But just to get you going right now, let's just kind of think about how it's used. So given that you do have all these different transforms, okay, we basically computed really based on that relationship what the direction of the vector that has to go from the surface to actually point towards the sun. Okay, we can now go ahead and use those to actually start seeing a little bit of geometry. So for example, we can use a fantastic function called the rectangle function, where the rectangle function just really takes a series of different transforms. It's just all those little vectors and just places a rectangle so it's in the plane. So back on this plane, let me connect that in. Okay, and let's see if we can go ahead and run this. Looks like it's doing its work right now. It's doing something. Oh, it's because I'm still locked up over here. So what this is doing is, you can see, let me Control G my way back over here. Not there. It's just basically going through and placing a series of different planes so that they're always oriented on the red-green axis, okay, and they're perpendicular to the blue. Okay, so the blue is the one that's actually facing the sun. Let me see if I can orient this around a little bit better. So you can see that. Okay, but let's actually sort of play around with this a little bit. The height and width, that's just sort of a dimension that I put together in there in terms of, Control G. Yeah, making them 2 by 2, that's fine. If we want to make them 3 by 3 or 1 by 1, that doesn't really matter. That's just kind of just the size of the planes in terms of what's going on. But let's see if we can make some sense of this. So the idea is we're going through, we're computing all these vectors that point towards the sun, and hopefully these things are all going to adapt and change themselves. And let's see if we can actually make that happen. Okay, here's the idea. Going to zoom that out. Control G back over here. Want to see if you can actually see them together. Okay. So the idea is, if I go through, see if I can change my sun over here, and change the sun from that location. Oh, you stop that. Don't play with me that way. As I move the sun, see if I can make it orient themselves. There we go. They're taking a little bit to catch up for me over here. You'll see that what's happening is the panels in the background start adjusting based on that location. We pull it to kind of right about the middle. Okay, you can sort of see the little panels over here sort of adjusting, just so they're kind of looking like that. Let's go ahead and try, right now it's pretty low in the sky. Let me move it up very high in the sky. You know, we can start to see the panels adjust to that too. Okay, now this is just creating a whole series of different panels that are kind of floating around over here, kind of in the geometry space over here. If we'd actually like to go through and have those be real panels that are floating around in the Revit world, we have another function we want to add in here. Take a look at it. Let me Control G out of there. What I want to do is actually use one more function. Oh, do I still have it there? There it is. Nope, I left it down there. What is it? Oh, let me go ahead. I'm going to open the finished one. I'm just going to show you that instead. If we'd like to take all those rectangles and convert them all to be real Revit geometry, there's a fantastic function you want to know about called model curves from a curve loop. So it's going to show you what that looks like. Again, I can take that model curves from a curve loop. And all that really does is it takes these geometries right here and creates a series of different real geometric pieces. I'm going to take out the other one down below for just a second so that won't clutter us up. Okay, and now let us take a look at this. Let me say let this run and run automatically. So let's go back over to Revit for a second. The idea is that what we would like to have happen is, okay, you can sort of see a whole row of these little panels right across the front. They're all sort of facing the sun. What I'd like to have happen is this, is that if I go through and move the sun, if it'll run. Oh, hang on. It's a little hard to see what's going on here. Let me try it in terms of moving it someplace a little stronger so you can sort of see the effect. I'm going to try moving it all the way over to late in the day. What's going on? Oh, hang on. I reopened a new file. I don't have the sun path selected anymore. I'm wondering, I'm moving the sun and nothing's moving, and this is bothering me. Okay, and the reason is because I opened this new file. Let me reassociate it with the sun path. Okay, now it's associated. Okay, let's see if we can make this work now. Okay, there we go. There's two little rows there. I'll hook up the other one. It'll be a little bit easier for you to see what's going on. What's happening is I have some old junk, kind of to your point, Natasha. There's all these which is sort of the old panels are still hanging around in there. I need to clean them up. But let me do this. It'll be easier probably just connect it in here and kind of show you. In the finished example, there's two different grids. There's a single line, there's a 2D grid. That's all that's really going on there. And let us see if we can make that work. So what's happening now is, relative to that sun path, everything's going to be sort of facing the sun. What'll happen is if that sun goes moving around, with a little bit of recalculation, hopefully all the panels are going to go moving around too. Okay, and they're following. So that's basically the idea, is that I can have a whole field of different panels, and what's going to happen is they're going to follow around as the sun moves. Their orientation will keep on changing. Okay, so that's really just the beginning. Because what we did here was just kind of taking the whole notion of the sun path and did something that says just based on its distance, or really what the location of the sun, let's go ahead and just kind of figure out really what the vector is that connects us, and then kind of place a plane perpendicular to that vector. But you're going to find there's all these other things we can start doing with the sun. We can start thinking about how the sun and the ray that comes from the sun bounces off different surfaces and where it's creating glare on other buildings in the neighborhood. We can start thinking about, just by the directionality of the sun, is there something we need to do with the shading on the building to sort of tilt the fins or reorient the shelf in such a way that it's always blocking the sun, so that the shade could always be perpendicular to the sun direction, based on whether it's high in the sky or low in the sky, or if they're vertical fins, based on adapting to wherever the sun's location is, to always either introduce whether you want to have as much openness as possible or as much shade as possible. Okay, or we can just start changing all sorts of attributes of our objects. So we'll continue with this next time, this whole notion of, great, given that you can sort of figure out where the sun is relative to where our object is, and think about how that's actually useful to us in terms of being able to adapt the object behavior so that it reflects what's going on in the sun. And then think about how we start putting that in a loop so that we can start testing different conditions and figure out what has the optimal behavior for what we're trying to drive. Okay, so that's where we will go next time. Let us adjourn for today.